No, it's Luli.
It's Lily.
What? It's L-U-L-I.
Yeah.
Alright,
Let's not about English and maths, please.
let's get started. So we're up to the next chapter, 5 now. So exponential and logarithmic functions. So first of all, exponential functions. Alright, so exponential functions, I have this form. We have the fx is equal to some number, and x is the power. And a can be any number except 1. If you have 1 to any power, the answer's just 1, so you don't actually get an exponential function. All you get is y equals 1. Alright, so if the a is greater than 1, then the basic graph would look something like this. So they would all have a y-intercept of 1, and they all curve around like this. And there is a couple of other points. So when x is equal to 1 or negative 1, depending on what a is, then the y value will be equal to whatever that a is. And over here, the y value will be 1 over whatever that a is. Now, if a is a fraction, so between 0 and 1, then it looks very similar. Still has that y-intercept of 1, and this time it curves around this way.
So A is a function.
So, yeah, I can put that. So 0 less than a less than 1. So a fraction. Alright. And so again, those points when x is 1 or minus 1. The y value again depends on what a is. Alright, so there's some key features, and that is that your domain there's no restriction on the domain, it can be any value, so your range, right, it's only above the x-axis, so the range is just the positive real numbers, and it has a horizontal asymptote.
Is this just for the first graph?
Oh, both.
For both?
Yeah. y equals 0. The x-axis is the horizontal asymptote, and the other thing is the key point that we're looking at is when x is 0, y is always 1, because anything to the power of 0 is 1. Alright, so we can have some translations of these, and we'll move on to that. You can also have reflections and dilations as well, and so we'll have a look and see what that actually does.
So all those features on every graph.
So this is our standard.
Yeah.
These are the features, and then if we've got some transformations, then these features may or may not move depending on what our transformations are. So if we've got a translation up or down, then the asymptote's going to move up and down. This key point's going to move up or down.
Wait, so this is a standard what? Exponential.
This is our standard exponential, a to the power of x. Alright, so let's have a look at if we have translations. So translations will reflect in exactly the same way as anything else. X minus h and a plus k on the end. Alright, so this is our translation in the x direction, left or right, and this is up or down. So if we want to write it like this in a mapping form, then our new x is the old one plus h, and our new y is the old one plus k. So h is translation left or right. And k up or down. Oops. All right, so if we're going to move up or down, then that's going to move our horizontal asymptote. Remember, the horizontal asymptote was the x-axis, so if we move up or down by k, that's going to move it from y equals 0 to wherever that k is. And of course the range will also change as well. So our range will be k to infinity. Now the other thing is that our key point in 0 and 1, that's also going to be moved, translated. Zero plus h and 1 plus k, which is h and 1 plus k. All right, let's have a look at an example. Alright, so y equals 2 to the x minus 1 plus 2 on the end. So, key things, our horizontal asymptote. Is that y equals 2. Alright, because the 1 there, that's our h. And the 2 here, that's our k. So y equals 2. Our key point. So our key point's moved to h and 1 plus k. So 1 and 1 plus 2, which of course is 1 and 3. Alright. So Alright, so horizontal asymptote y equals 2. That's across here. Our key point is at 1 and 3. So 1 and 3. And it curves around like so. So seeing as it has a Y-intercept, we need to find out what that is. So for our Y-intercept, x equals 0. So that would be y equals 2 to the negative 1 plus 2, which is
0.
2 to the negative 1 is what? It's a half. Negative power 1 over. 1 over what? 1 over 2. So 2.5. So this point here, where it intersects, is at 0 and 2.5. Alright, reflections. I'm going to look at reflections and dilations. So we will look at those.
The reason why the one for x equals 0, why is it not putting 0 into the equation? Why is it not putting 0 into the equation? X is negative 1.
reflections.
0 minus. Makes sense.
So there's two types of reflections that could happen. Firstly, in the x-axis. So if it's in the x-axis, it gets reflected down to here. So all the y values change to negative. So x and y, the new x stays the same as the old one, but the new y is the negative of the old one. So the way that appears in the equation, so if the equation is y equals a to the x, that will be translated, or not translated, transformed to, once we change y to negative y, then divide up everything by negative 1, it ends up looking like this. So if you've got a negative out the front of all of this stuff here, and it's a reflection. And in the y-axis, it's reflected this way. So the x values are the ones that change to the negative. So the new x would be the negative of the old, and the new y is the same as the old. And how does that look in the equation? In the equation, there's a negative in front of the x up here. Alright, dilations.
See, I thought that was hard. Now I
Alright, factor k from the y-axis. So if we take a point and we're doing it from the y-axis, then it's moving that way. So what changes? The x changes. So what that means is x and y, they change. The x, the new x, it's k times whatever the old one was. And the y stays the same. So in where am I? So in the equation will transform for that, from that to y equals a to the kx. And of course we could move it from the y-axis, and if we do move it from the y-axis, this point here, from the x-axis I should say, from the x-axis, this point is moved to up there, so it's the y value that gets bigger.
effectively the same as a transformation.
Yeah. Here's the transformation.
Oh, I mean,
Can,
no, yeah. Just like.
yeah, well, yeah, except it's a factor. So if it's 2, then that's twice as high, and then that's twice as high. So, whereas the translation just moves everything up.
Same damn thing.
All right, so when that in the equation,
I think it does.
it would look like that.
No. It's like the same as the.
Right, let's do one example.
Hang on. Yeah, but that's not right. If you look up I, you ready? It'll be in equation. Boy, if you scoopy. Sorry.
IE means in other words, and EG
Yes.
means, for example.
No, but that's what it stands for.
Yeah, that's what it stands for. Id est, which means
Oh.
in other words in the chat in Latin.
Here I am reading this article.
So somehow we've turned math into English
Well,
once again.
IE stands for in equation. They're just in maths. I mean, in equation.
Is there any?
I think it's fine. What's his? Whiteboard rubber.
All right, so sketch and state the range. So when we look at this, there's a few things that we can see that have happened because we got these 3 things there. So if I start here with this one here, this negative here is there's a reflection in x-axis. This -1 up here is a translation which way? Yep. Right.
That's right.
So when x minus 1 is equal to 0, x is 1. So that's to the right, 1. And the -2 on the end is a
Down.
Translation
down 2, which then means that we've got our horizontal asymptote where?
2. Negative 2.
Yep. Y equals -2. All right. So if I sketch that stuff over here, I know I've got a horizontal asymptote across there like so. So it would be handy to find some other points that we can put on. So the Y-intercept is, no, obvious one that we do. So Y-intercept is when x equals 0. So y equals negative 10, 0, minus 1, minus 2. Stick all of that in your calculator and you get it's a negative number. 2 and 1/10. Right, so this bit here is 10 to the minus 1. Negative power is 1 over 10, 1/10. Negative 1/10 minus another 2 is negative 2 and 1/10. So that's way down here somewhere. So that point there, that's not going to work. So that point there is 0 and 2 and 1/10. All right, so it's going to curve around this way like so. Be nice to know whereabouts it goes here. So you choose an x value, and x equals 1 is a nice easy value to choose. So when x is equal to 1, y would be equal to negative 10 to the 1 minus 1 minus 2
Negative 2.
and negative 2. Alright, so negative 2. No, it's not. It's negative
Negative
3. This is negative 1, 10 to the 0.
Because anything to the 0 equals 1.
Negative 3, that makes more sense. So it is negative 3, so it goes through. Yep. So it swings around like that. And there it is. Done. Range. That's the other thing that was asked. So what's our range? Range is all down here.
So negative 2, negative infinity.
Right, which one do we put first?
Negative 2.
Infinity.
The smallest number always goes first, so in this case the smallest number is negative infinity to negative 2. Alright, so convention is you put the lowest number first. Alright, and that's our range.
Everything you like in math, you're wrong. That's how you do it.
Alright, exercise 5A, and I'll give you a work plan. And we can make a start.